we need to find out the derivative of the following. So we will begin by considering u to be equals to tangent inverse of 1 minus x divided by 1 plus x. And we are going to consider v to be equals to square root of 1 minus x squared. Our job will be to find out the derivative of u with respect to v. For that, we need to find out first derivative of u with respect to x as well as derivative of v with respect to x. Derivative of v with respect to x is very straightforward, so let's find it out. We have derivative of v with respect to x is equals to derivative with respect to x of 1 minus x squared raised to the power of half. So here we have transformed the radical form to its exponent form so that we can use the power rule, which will be half multiplied to 1 minus x squared raised to the power of half minus 1, which is negative half. And using the chain rule, this will get multiplied to 1 minus x squared and its derivative. That is half multiplied to 1 minus x squared raised to the power of negative half multiplied to derivative of 1 minus x squared as simply negative 2x, which gives us derivative of v with respect to x equals to negative x. So here 2 and 2 gets cancelled, divided by square root of 1 minus x squared. So we'll label this as number 2. Now we'll come back to u. So here, in order to find out derivative of u with respect to x, first we'll have to simplify the expression, the trigonometric expression on the right hand side. So we will simplify this by using a trigonometric substitution. Let's take x to be equals to tangent of theta. That gives us u equals to tangent inverse of 1 minus tan theta divided by 1 plus tan theta. Now here we're going to make use of the fact that tangent of pi over 4, that this value is always equals to 1. Now what we'll do is we will rewrite our expression as tangent inverse of, so in place of 1 we will write tan pi over 4 minus tangent of theta divided by 1 plus, so here we have tangent of theta in the denominator, so this can be also expressed as tangent of theta multiplied to 1, so that we can rewrite it as tangent of theta multiplied to tangent of pi over 4. That's been done, so that here we will be using a proper identity, tangent of a plus minus tangent of b, that will be equals to tangent of a minus tangent of b divided by 1 plus tangent of a multiplied to tangent of b. So in our case, if we consider a to be equals to pi over 4 and b to be equals to theta, then the expression, this particular expression can be replaced with u equals to tangent inverse of tangent of a minus b. So we have pi over 4 minus theta. Now we know that tangent inverse of tangent of pi over 4, that will give us simply pi over 4 minus theta. So this is now simplified. Now we considered tangent of theta to be equals to x, which means theta will be equals to tangent inverse of x. So we will substitute this in place of theta, which will give us pi over 4 minus tangent inverse of x. So this is now u in a simplified form. Now let's find out the derivative of u with respect to x, which is equals to the derivative of pi over 4, that's a constant, which will be equals to 0, minus derivative of the inverse tangent function, that's a standard formula, which is 1 over 1 plus x squared. So this is number 1. So now we have derivative of u with respect to x as well as derivative of v with respect to x. So let's write it down here as well. So derivative of v with respect to x, we obtain the value as negative x divided by square root of 1 minus x squared. So this is number 2. Now in order to find out the value of derivative of u with respect to x, all we have to do is divide 1 with 2. The derivative of u with respect to v is equals to derivative of u with respect to x divided by derivative of v with respect to x. So we get negative times 1 over 1 plus x squared. So this will be multiplied to the reciprocal of dv over dx, which is negative of square root of 1 minus x squared divided by x, which finally gives us negative square root of 1 minus x squared. So here negative and negative becomes positive, divided by x multiplied to 1 plus x squared. So this is the value of our required derivative.